Okay, so here's a mechanism video on the Diels Alder reaction, and I mean to say very little here, but I'm going to accentuate the main points. We oftentimes will say 1,2-butadiene plus ethene, and under the right conditions, which we rarely talk about, almost never talk about, is going to give us a six-membered ring, a six-membered alkene ring, right? That's the reaction that we have memorized. And I have suggested that I never think about it like this. I'm always going to think about it like this. Boom, boom, boom. I always think about it in terms of its mechanism because it's so complicated in terms of numbers of atoms. Actually, the electron movement itself is not so bad, but the number of atoms is just overwhelming. So I'm going to do it like this. I'm going to go 1, 2, 3, 4, 5, 6. Okay? And I'm going to, and now we're ready for the mechanism, right? These pi electrons come and attack that carbon. These pi electrons come and attack that carbon. And these pi electrons come and go in between there. Alright, so we end up with that. Now that's the entirety of the mechanism, but I do want to point out some things that are a little subtle. If this is true, if this mechanism is true, what do we know about this atom right here, atom 5? Atom 5, its electron pore is better, right? What do we know about these pi electrons? Which I'm going to call 3-4, right, because it's between atoms 3 and 4. Pi electrons 3-4. Electron pore is worse, right? Because these guys are the attackers. And the attackers are always, we're always looking for the attacker when we're doing mechanisms and the target, right? And the targets, the attackers are electrons, so they need to be electron dense. The target is a nucleus, and it's more vulnerable to electron attack if it's electron poor. Okay? So atom 5, electron pore is better. The pi electrons between 3 and 4, those right there, electron pore is worse. Okay? And what about atom 1? You finished that. Electron pore is better or worse? Okay? Alright, that's all I'm going to say. That's all I'm going to say about what those implications are. Let's go now to a question. Let's compare this. This will be the baseline, okay, to this. What are we going to do to make this better? Let's go with this rule right here. This is always how you should be studying. Let's go with this rule right here. Atom 5, electron pore is better. So let's make this reaction better. This will be the baseline. What are we going to do on here? Put an electron withdrawer on there. Right? This is going to be better because this is rule number 1. Rule number 1 illustrated. Okay? How about let's illustrate rule number 2. Pi electrons. The electron pore is worse. Let's think about shoveling electrons into that system. How can we shovel electrons into that system? Right? We can get electrons into or out of the system through two methods. Induction and resonance. Which did I use here to pull them out? Induction or resonance? I used induction, right? If I'm pulling them out. See that? Electron withdrawal. Okay. You know, an even better, because this can resonate into there, right? So an even better electron withdrawal would be, wow, watch this, NH3+. It has no lone pairs of electrons that go into the system, and it's electronegative. It's pulling them out. That's a great electron withdrawal through induction. And it cannot resonate into it. That's a great one. What about this? How can I get electrons into the system? How about I do that? Right? See, that's going to resonate into the system. Boom. Okay, so this electron density is now richer. Okay, through resonance. And then I'm going to ask you, to think about what you can do for atom 3. Okay, so the couple questions I've given you here are, I can only think of one of them, and that is, how are you going to, the first question was, is electron pour better or worse for atom 1? And the next question is, how are we going to make it better or worse? Okay, so there's the mechanism. This is the big part of it. Oh, last thing I want to say about this is concerted. All these things happen at once. Okay, and we maybe have implied that.